be looking at the last part of question 22d, that is, from the 2013 revised higher physics paper. And it states that this seatbelt is designed to stretch slightly during the collision. Explain in terms of forces and advantage of this design. So this is your standard question about impulse really. And let me just, again, as I've done before, I'm going to just clear some space here so that we can answer the question correctly. Well, the first thing to say, I'm just going to write down the equation for impulse just so that that's clear from the beginning. Impulse is Ft, and that's equal to the change of momentum, which is mv minus mu. Sorry, that didn't turn out very well. U. That could also be written in a number of ways, mv minus u, all in brackets, but we'll just leave it like that at the moment. So what's happening here is that the seatbelt is designed to stretch, and what that does is that increases the time of the collision. So that's the first thing we need to say, really. The time of collision is increased. And so the time of collision is increased, but the change of momentum does not change. You see, what happens is this, the crash test dummy in the car goes from a initial speed of 13.4 to a final speed of 0, and that always happens regardless of how long it takes to stop. It could hit the dashboard instantly without a seatbelt. It would still go from 13.4 meters per second to rest. And so the change of momentum, this part here, is constant. So that's the next thing that we need to write. So we'll do that here. The change of momentum is constant, or the same. Okay, and so if that's the case, if the time of the collision is increased by having this slightly stretched elastic in the seatbelt, and this does not change, if that's fixed, then if this formula holds true, if this equality is true, and that number there gets bigger, t increases, then the force must go down to keep this value of momentum, or the change of momentum, the same. And so our final statement written here is that the average force on the dummy is reduced. Okay, so I hope that's clear, and that's true for any kind of situation. If you've got a helmet on, what the helmet will do is it will increase the time over which your head comes to rest. The change of momentum will be the same as it is before, so if the time gets bigger, the force must reduce. The same is true for things like airbags as well, which is also a common question at this level.